So, hello everyone. My name is Vladislav, and today I'll be telling you about JetBrains AI. Yeah, it's actually a bit unexpected for me that there are so many people willing to know about AI, not about new project of Java. Take into account that Brian is kind of in this next room. So, yeah, my name is Vladislav. I'm the team lead of JetBrains AI, so I'll be telling you about a bit about JetBrains AI and telling about the way we are kind of implementing it. So there would be not so many information about, I don't know, the product. You've already seen this during the talk of Anton Arkhipov today on a keynote. He has been presenting the demo of AI Assistant in IntelliJ. We have it kind of in ReSharper, in Fleet as well. There are a lot of things. I'll be telling a lot more about kind of the way we are implementing it, the way JetBrains AI platform is built, and the way kind of a machine learning works, starting from the basics. Yeah. So, just to start with, who is aware what is machine learning, how does it work, and considers themselves as a machine learning engineer? Okay, so that's why we will have a lot of basics about machine learning. Yeah, let's start with a brief introduction into JetBrains AI, for those who have not been on a keynote. Shame on you. So what do we have? First of all, JetBrains AI is a chat. It's running in this specific GIF as a GPT-4. So actually, we are sending the questions that you are kind of asking in AI chat to GPT-4. We are providing some context. We'll be talking about it a bit more today. We are providing some additional information that you are kind of running Java project. But in the end, it's still kind of a large language model trained by OpenAI right now. That is not kind of a set in stone, and that it answers you kind of with the results. What do we have else? We also have actions. The whole kind of idea of AI Assistant, JetBrains AI, in terms of IDEs, is to integrate AI as much as possible inside your IDE. So we are providing you not only with the chat, you can kind of go to chat.openai.com and try the same thing, but we are providing you with the experience that is built inside IDE. So we are providing you with intentions. We are even integrating some things inside the code itself. So there are a lot of things that are integrated into IDE, and we do not expect that you would be kind of working with them through the chat. We are integrating it into the experience that you had for last 20 years. For example, we have inlay intentions. Here is the start of the GIF, but you may see here that we are kind of suggesting the documentation. So you can just click in the inlay, and we are creating the prompt, asking GPT-4, ChatGPT, something that is behind the scenes, and it generates you the documentation based on the codes that we have, based on the context that we provide, based on the project structure, based on a lot of things. But in the end, you just get an inlay that you can kind of click on and get the documentation that would fit your project. And since GPT-4 specifically is a very powerful model, we also will be talking about it today, it's working quite nice. Finally, one of the kind of also cool things is commit generation. We also have kind of additional new buttons. Most of you, I think, already have seen in the merge. When you are kind of having a merge conflict, the idea presents you with option to kind of accept left, accept right, and perform after magic merge that is kind of based on formal methods and automatically tries to, using PSI and understanding of code, merge the things. We're doing now it with AI as well. So, for example, you may see in commit generation a button that you can click, and we are using diff, we are using the context, we are using the history to automatically kind of generate commits that you would generate in your application, that you would read or write in your application. And we have some even built-in things that are not really obvious to see. For example, we have pretty cool renaming that has been already there for, I don't know, 10 years already. And it has been built on formal methods. So all the kind of suggestions that you see each day when you are renaming something are actually a few heuristics that we are using to generate names that may or may not likely be kind of the ways you want to rename the function. But with ChatGPT, with GPT 3.5, with GPT-4, we are finally able to provide the code to the large language model, and it generates you the renaming. And the renaming would be quite nice, since the large language model actually understands what is going on inside your code. And this is one of the, I think, greatest examples of the way we are willing to integrate AI into IntelliJ IDEA. So you're basically not kind of interacting with something completely alien to the IDE. You're interacting with IDE, and you get some AI inside of it. And you don't care whether it's AI or not. It's just the instrument for us to provide you with better experience. And this better experience, for example, involves large language models that understands your code and tries to rename things better. You can actually check our booth. Anton Arkhipov shows pretty good example where you have kind of an algorithm with all the variables renamed to D1, D2, D something, and the large language model understands just from the way algorithm has been written what this algorithm is and suggests that D1 is probably, I don't know, middle, D2 is prefix, D3 is suffix, and the whole thing is called some way. For example, we can do the same thing with Euclidean distance. We can just kind of rename all the parameters to something completely ununderstandable. And for the human being, it's really hard to understand what those variables do. And the large language model, based on the kind of the context and understanding of the way it works, would provide you with better renamings. So, what is JetBrains AI? Basically, JetBrains AI is a system in all JetBrains products that is powered by different machine learning models that we provide as a part of JetBrains AI. It is included in IntelliJ IDEA, it's included in all IntelliJ IDEs, it's included in Fleet, it's included in ReSharper, there is working prototypes for UTrack, Space, and so on and so forth. So basically, JetBrains AI is a platform that we are using internally to provide different AI functionalities inside all of our products. And since we're kind of on Java conference, and I've been explicitly asked not to talk about Fleet, I'm showing GIFs of IntelliJ IDEA. So, to understand better how does it work and what we do have inside, we need to start with the basics. And since it's not machine learning conference, we'll be talking about what is machine learning in kind of a very simple concepts and simple terms that is. I've been asked additionally by our ML team not to say things like the model understands, the model explains, the model has knowledge. That is all kind of incorrect, because the model has kind of probabilities and it generates something. We will talk about it. But actually, I'll be using kind of more simple terms like the model explains, the model understands, because we are perceiving it that way. So, and we'll start with kind of a brief introduction based on golden retrievers, surprisingly. So, what is machine learning? Let's imagine that we have, that would be kind of a simple introduction to machine learning and into machine learning theory. Once again, I'm kind of using simple terms, and I'm not trying to kind of get into some debates about whether machine learning is approximation or not. There are kind of a lot of theoretical talks about it. So let's imagine that we have a function, kind of a global knowledge, a global ability of human being to decide whether the image contains golden retriever. So if you know kind of what golden retriever is, you can take a look at the image, or you can take a look kind of at the dog, and you can decide whether it's golden retriever or not. You may not be kind of 100% correct, but most of the time you kind of understand that this is a golden retriever, right? And this is kind of existing, I would name it original function. It's existing ability in the world, in the nature of human being to recognize some breeds of dogs. And it's extremely hard for us to understand the way it is working. We can do some brain researches and try to kind of deconstruct the way we are doing it, but it's extremely hard to do it, and it's also extremely hard to implement it in code. There is no kind of 10 ifs. If this dog is gold, it's golden retriever. So it's actually quite hard. And this is the original function that in a lot of cases we would like to kind of implement. We would like to train some function that tells us that this image contains golden retriever, this image does not contain golden retriever, or doesn't contain a dog at all. This is kind of the task that we have. We need to train this function to recognize whether this image contains good boy / golden retriever. So, training, which you may have heard a lot around machine learning. All machine learning are doing is training. So kind of a software developer have compiling process. Machine learning have training process. The beauty of machine learning is that training takes 2 weeks, so you can even not take a vacation. You kind of it's training. So training is the process of inferring approximation of original function based on examples. What does it actually mean? We have a lot of examples of golden retrievers, and we train some function. This function that we are training is called, in most cases, architecture. It's the functions that can be kind of changed to approximate something. We have a lot of examples of golden retrievers, and we train this function to tell us that this is a golden retriever, this is not a golden retriever. So in the end, we get some function that, based on examples that we have, tells that this is a golden retriever, this is not, with some accuracy, like 98%. What is the problem? Actually, what we have done, with this training process is that we've represented our dataset. We have a lot of examples. Our training function is now capable of telling that this is a golden retriever, or this is not. But what we actually do want, and what is the kind of a holy grail of the whole machine learning, is the thing called generalization. We actually do not want to train function that is kind of working for this specific dataset. We can just use this dataset. This dataset is itself a function. Generalization is the property of the model to be able to work with examples outside of training set. And with it, we do expect that our trained model would be also understanding that this image is also golden retriever. It's kind of a bit different. All the images are generated by Adobe Firefly, so it's kind of AI synced also. This image is a bit different, but our model should also understand that it's not about kind of images, specific bits that we have. It should understand that we should take a look kind of at the fur of the animal, we should take a look at the color of the animal, and we will understand that this is most likely golden retriever. And generalization is extremely important, because without it, kind of no machine learning is working. But with generalization comes the price, and it's named erroneous responses. So any trained function is actually an approximation of something existing in the nature in most cases. Our ability to understand that this is a golden retriever, our ability to understand that this is a car, our ability to understand that this is a wall, and we should not drive into it. So there are kind of a lot of things that we need to train. And each such function would produce erroneous responses. And even our trained function, for example, would think that this is a golden retriever, because it's also gold, it looks pretty much similar, and it's also on the grass. So, very simplistically, the whole machine learning process is about having something in the nature and performing the training that involves generalization that provides us with functions that we are able to run on our computer, on our server, on a number of our servers, that will be providing us with the result. So basically, once again, machine learning is the way to infer a function that connects inputs to outputs without knowing the original function. I've been asked by our ML department to add kind of the normal, as they say, description of what machine learning is, not like golden retrievers. How does it connect to the whole thing that you see kind of around you? That thing is basically a lot about large language models. Large language models that you see as a ChatGPT, I don't know, Claude in Anthropic, about Google Palm 2, a lot of models that exist right now, Gemini of Google. They all also have been trained, and they have been trained also on some original functions that exist in the world. So, there exists also in the world the ability of human being to predict the next word. So, for example, if myself is saying I have kind of the part of the sentence my dog is, I can predict that most likely, since I have a golden retriever, not now, but will, hopefully, the next word would be my dog is golden. And once I get my dog is golden, I would predict that the next thing is retriever. That is kind of a ability of each human being to kind of model the probabilistic theory, the probabilistic model around the language. What it means basically is that you can predict the next word. So you are kind of seeing the start of the sentence, you have your personal experience, you are predicting that the next thing is golden, and the next thing after it is retriever. How it connects with language models that we see today? Basically, language models are also training on the very same function. We are actually providing it with some previous context, my dog is, and they are generating something next. Since they are training on some training corpus, you have a lot of text. For example, there is Zepile, which is a dataset of basically everything you can find in the internet. They're predicting a few different ways. If you have kind of a personalized language model, they would be predicting that most likely my dog is golden with 55% probability. My dog is golden what? Retriever. We also see here that there will be erroneous responses, because we are also trying kind of to not train the model that is kind of predicting something completely out of the blue. We are training the model that should predict something that is kind of existing in the world that we do expect. That is why kind of we do expect generalization. We do expect that it would work with any text. The same way as, for example, GPT has been generating something about Mars. The GPT-2 has been able to generate some novels about unicorns on Mars, something like this. But it still will always have erroneous responses, like my dog is golden, what bucket? Well, why? Just because. That is the thing kind of machine learning engineers live right now with. What can we do as well? We can not only kind of predict the next word, we can predict, it's called fill in the middle. We can predict what should be between a few words. So we have my dog is, and we have retriever. And we are predicting that in 75% of situations, we would have my dog is golden retriever, and 25% probability is good retriever. That is fill in the middle. The whole thing still is about modeling some language. And once again, from our machine learning department, language model is a function that generates probability of word sequences based on training corpora. So you have a big training corpora, for example, of text or Kotlin, and you are generating some language model. And this is where kind of things become quite interesting. We can do the same thing and train code completion. This is the way we're actually doing it in JetBrains AI. This is the way it still will be working kind of in Google Gecko Duet AI. This is the way folks are training ChatGPT. Basically, everything is working this way. So you have kind of a prefix. You are generating next token or next word, depending on the way you are doing it. And there is quite natural and straightforward approach. We have kind of a lot of Kotlin files. We take all of them, we train language models that tells us if you have this prefix, the next token would be, and we get kind of a one-line code completion. Most of you, I hope, have seen it, like in Copilot, or hopefully will soon see it in AI assistant as well. So, but still, it's not kind of quite, interesting. So this thing existed, like I think, for 10 years already, but no one has been talking about ChatGPT, about the way it will change kind of the whole world around us, and that is why there have been created large language models. What is important? Large language models are basically language models that are large, so they are just big, very big, very, very big. And what is surprising and quite unfortunate for ML engineers, the whole thing about kind of providing better quality is about kind of having more parameters and more money. So there were kind of 10 years, I think, already research about the ways you are trying to intelligently change architecture, and it will provide you better accuracy. And then comes OpenAI, and they have better architectures, but they also have quite a lot of money. They just invest them, and they get better quality. So the whole thing now is about kind of the number of servers you have, the number of money you have, and the number kind of parameters that you can train. The bigger the model, the better it is. And large language model, once again, is just very big language models, which is unfortunate for machine learning, since they've been kind of publishing papers for 10 years about the ways you can a bit change architecture and improve it by 1%, and then you kind of just make 10x more parameters and you improve it by 10%. So it's all about money. Why large language models matter? First of all, the thing that has kind of amazed the whole world, it seems, size matters for knowledge. Basically, the whole language models that we've been talking previously is about kind of you have prefix, you are generating next word, remember? That is quite important to understand, that basically the whole large language model thing, machine learning, is about very simple function, like this is a prefix, this is the next word. And from it comes whole intelligence. Because we have a very big size of the model, like, I don't know, 175 billion parameters, as rumors says for ChatGPT, or 1 trillion parameters, with a mixture of experts, as the rumors says for GPT-4, the model is capable of kind of remembering a lot more information. The model is basically, once again, approximating the way you would predict the next word. And if we are kind of training it on the whole data set of the whole world, it would absorb a lot more information. And for example, about golden retrievers, it would know that golden retrievers were developed by whom? By Lord which Tweedmouth, where in where Scotland, in the which century? Late 19th century. It's actually just kind of predicting token by token based on the previous prefix. This is answered by GPT-4. Size actually matters for knowledge. The whole thing kind of between GPT-2 and GPT-4 is that we have a lot bigger size, and it just absorbs a lot more information and is capable of retrieving it and representing it back. Also, size matters for intelligence. We'll talk about it a little bit more in details later, but size matters for intelligence. We are able actually to train some specific models that are not kind of just predicting the next tokens. They still will be predicting next tokens. It's all about it. But those models would be trained to instruct would be trained on instructional data set. So they would not expect that they need to complete something. They would understand the instructions that you send as an instruction. For example, when I'm talking to GPT-4, I'm telling it to write a poem about golden retrievers, and it tells us in fields of gold they romp and play, retrievers in the light of day, by Lord with mouse designs they came, to fetch and carry without aim to claim. That is quite good poem, I would say, about golden retrievers. Also, here we see that GPT-4 is intelligent enough to understand that it has some instruction, so it needs to generate something which responds to this instruction, not just complete it, because a simple completion model would just complete it, write a poem about golden retrievers, or write a poem about something else. It understands instruction. But what is also important, it still has knowledge, and because of it, it's capable of understanding that they have been kind of created, designed by Lord with mouse. It even produces a pun about the way they are called, like retrievers. Because of it, they've been came to fetch and carry without aim to claim. It also produces a pun about the name golden. They are golden, that's why they are gold. And they romp and play, they are very playful creatures. It's actually pretty hard to kind of create this poem out of the blue, and GPT-4 is using its enormous size to fetch the knowledge and its intelligence to kind of understand that it's instruction and it needs to kind of respond to it. What can we do with it? The simplest approach, we already had kind of a one-line code completion. Let's just implement multi-line code completion. Basically, it's Copilot. Most of you, how many of you kind of have used Copilot at some point? There's not so many, actually. Doesn't kind of we have another statistics based on IntelliJ, but yeah, I would expect a lot more folks just taking a look at the plugin marketplace of our plugins in IntelliJ. So yeah, what Copilot can produce? Copilot, default Copilot, not business one, is producing you with completions. And what is different about large language models, even in comparison with language models that we had for Kotlin, is that we have some instruction, example of language model usage, right? And it's hard for kind of a small language model to understand that we are actually saying that example of language model usage should be underneath. And what is a language model? It should understand what is a language model, that there is a concept of usage. It's also quite hard to understand it for a small language model. But with large language model, we just say what we want, and the model generates it. And we see here also a lot of examples of kind of intelligence and knowledge in large language model. We see that, for example, this model understands that language models are predicting something. And if we're talking about GPT-4 and other big models, they most likely have been trained also on the whole GitHub, so they do know that lm.predict is kind of the way to predict something with language models. So it just produces us with a few words the whole kind of example of what we have been wanting to create. So LLM in this case is already acting like kind of a companion, not just completion. So it's working like completion, but you are perceiving it as a companion who actually understands what you are willing to do. So, but what even better than completion? Even better than completion, for example, is chat. And to create chat, we actually need the last step. We have kind of a machine learning, we have language models. Language models are just predicting next tokens. Next, we have kind of the thing about language models are predicting the next tokens. After it, we have large language models, which are just very big language models. And the next step is actually fine-tuning. That is extremely important nowadays, the thing in machine learning. And when we're talking a lot about with our customers, everyone is asking about fine-tuning. So fine-tuning is just the process of adapting trained model to a new task with additional training on specific examples. A very simple example based on dogs, once again. For example, I have my language model trained that is saying that my dog is golden. But for some reason, I don't know, I have changed the dog to case hunt. Do anyone know what case hunt is? Yeah. quite a lot of folks. Okay. So case hunt is completely another breed of dog. And I'm the owner of case hunt, and I want my language model to know about it. That is why I'm fine-tuning it. I'm providing it with a few examples of how case hunt is good breed, that I am the owner of case hunt is good, blah, blah, blah. I don't know, 20,000 examples, and kind of I'm fine-tuning on it. The resulting language model is still kind of a language model that is predicting text, but it has a bias towards case hunt. like most of the case font owners. So with fine-tuning, we can do a lot of very interesting things. And the first thing that has been kind of the most interesting and most kind of known in community is chat. And now kind of the probably most interesting slide in this presentation is the fact that the chat large language models are also completion large language models. For those who have been using language models, large language models, or have been using, I don't know, as far as I remember, Llama 2, for example, requires you to kind of provide it with markup by hand. Those already know, but actually, ChatGPT, GPT-4, Cloudy 2, AWS Titan, I don't remember any other names, but all of those models are actually just completion models that are predicting token by token. They do not have any kind of understanding of what chat is. They don't care. All they are trained on is called chat-ML markup in case of OpenAI. That is just text that you are providing and telling and fine-tuning the model, saying that we will be working in a world where our data looks like this. It has IAM start, it tells us the role, and then goes some question, for example. It has IAM start, there goes the role, and there goes some question. Because we are able to fine-tune, we are able basically to change the model that has been trained on a lot of data to give it some bias. We are able to bring it into the world where actually all the data looks like this. And that is why kind of a ChatGPT is able to interact with you. ChatGPT, chat.openai.com, is basically providing you kind of with a sweet UI that is just parsing of those texts and making them kind of in the front end look like messages. So the whole thing is just completion model that has been fine-tuned to have instructions, to have chat-ML markup. What we can also do, and what have been done for GPT-4, for GPT-3.5, for Llama Instruct, for a lot of models, is also instruction dataset. We need LLM to understand instructions. And to make sure it's possible, we are not only kind of fine-tuning it on a chat, we are providing it with instructions. So we have kind of write a poem about golden retrievers, and we are providing that. Here's an example of the poem. We are training it at the same time on chat-ML markup and instructions, and fine-tuned model will understand that basically it exists in the world where there are instructions and it should respond this way. There are chat-ML markup and it should always respond in a chat-ML markup, and it all will be working. So this is kind of the way it works now, from machine learning to language models, large language models, and what is extremely important, the fact that all of existing models are generational ones that are generating token by token. They do not know anything about graphs or something, anything about chats. Now let's discuss how do we kind of use it in JetBrains AI. And there are quite a lot of applications for modern AI technologies. And what is also quite important, actually, that most of those applications existed like 5 years ago. So it has been possible to implement one-line code completion, few lines code completion with existing previous models. They were big models, but since kind of the whole world now is crazy about AI, it's a lot more, it's a biggest priority now for kind of even JetBrains to implement it. So one-line code completion. This is the simplest example. We've already seen it. We kind of just creating a dedicated language model. We have a big data set of Kotlin. We are training the model that just predicts the next token, and everything is great. Everything is working out of the box. This is kind of the simplest task that we can give to even intern. And kind of he or she will be training it in a few, I don't know, days, I think, with PyTorch. But there is kind of a problem. In a lot of cases, developers are actually not writing kind of the last line of the code. They're editing something. And for it has been created fill-in-the-middle technique. Fill-in-the-middle technique is devoted to beta generation. It's, if we are talking kind of about the way it's implemented, it's actually changing the way we are modeling language. We are telling that we're now training not on dataset of Kotlin, we are training on dataset of Kotlin that consists of prefixes and suffixes at the same time. So we are kind of not predicting from after prefix what goes next, but you are predicting what goes next after prefix if suffix was this one. And this is the way kind of most of the developers actually work. They have something that they are editing inside their file. They are not kind of writing it from the top to bottom. And fill in the middle improves greatly the results. And for example, we may see here that we have kind of a fun main language model, prefix, my doc is golden, and also we already have some postfix. We know that we will be predicting something and that we expect that generation would be equal to something that is called expected. And when we are performing kind of a generation here, val exp, our language model, seeing prefix and suffix, understands that most likely, first of all, it should be expected, because kind of this variable is already used later. And if we are actually using a very big language model, it may even understand that most likely the next word would be retriever. But it requires a lot more kind of a knowledge, a lot bigger size, because we're actually asking this model to kind of understand that we have string, my doc is golden, there is kind of an action predict that should generate next prefix, and basically the whole thing that I'm telling you right now, model should understand to kind of generate this completion. So it would be working most likely in bigger models, but most likely would not work kind of to generate retriever in smaller models. But it improves greatly the quality. And this is kind of the simplest way we can implement JetBrains AI, and kind of a Tab9 has been implementing it, Cody, I think, implementing it this way, Code Whisperer. There are a lot of competitors right now. We basically have JetBrains AI platform that is running in cloud. We can even have smaller language models that are running locally, which are called full-line code completion. You can download the plugin. It's in plugin marketplace. And we are just running it kind of a just simple language model that has been trained. We also need security and anti-fraud. You may see it here. Unfortunately, AI on a hype not only for kind of developers, but also for a lot of hackers who are creating special platforms providing kind of OpenAI access through ways they kind of hacked different systems. And that is why kind of we have a waiting list, we have a lot of things to make sure that we are not just providing a way to access OpenAI to someone who is not actually using JetBrains AI. But yeah, that is the simplest example. We have API, we have Kotlin language model, we are just sending prefix, postfix, and get completion. Everything is working out of the box. What should we do next? The next thing after Tab9 that has been released, I think, 5 years ago and included this feature is multi-line completion, and this is the thing that Copilot has. So this is basically a large language model generating something based on prefix. It can also use fill in the middle, but since it's a language model, we can provide it kind of with just words like prefix is the prefix, postfix is the postfix. Please generate between prefix and postfix. In most of the cases, it would work. And in this case, we kind of get multi-line completion. It works pretty nice. This is the way Copilot is working right now. Everything is cool. And AI platform becomes a little bit more sophisticated, but still kind of pretty understandable. So we have smaller language models for one-line code completions. We have bigger models for multi-line code completions. And we have those bigger models as hosted one, or we're integrating with OpenAI, Anthropic, AWS, you name it. So quite cool. But what is important is that language models actually are knowledgeable and instructable. That is why it seems we may provide even more information to it. So we can, for example, just add the context, write into, I don't know, file, provide it in some other way. Here I'm providing it as a comment. And here we are providing context of what IntelliJ knows about your way kind of working right now. So IntelliJ knows that you are running, I don't know, Kotlin 1.9, that you are using libraries. Let's assume that there is only one library, Kotlin serialization. That there are some related files that has been imported that may seem pretty similar to this file. I'll tell about it a bit more in details. It knows about libraries. It can generate a big context that will be kind of considered by a language model as instruction, and at the same time as kind of some additional knowledge that it should use during the generation. So we are kind of providing the whole context, and it works out of the box. That is why we need something that is running inside IDE. We have the thing called prompt. It's basically the thing that we are sending to a large language model. Doesn't matter whether we have it kind of hosted, on premises, OpenAI, anything. And we are using a lot of special context contributors that has been implemented, for example, in IntelliJ, in ReSharper, to collect information about what we're actually generating and what you are expecting as a completion. We need data about the file, we need some data about the project, structure of the project, languages, libraries. We need some data about requests. You may not kind of call completion, but instead you may be calling, for example, specific things that we call code generation. You are kind of providing the input for us. I'll be telling about it also a bit later, but it's basically the thing you have an input and you are saying generate function this one, and we have specific requests from you, not just code completion. We have information about your project. We may have some information about behavior that we, for example, know that previous files that you've seen those one, and most likely they should be included in context because they are kind of in context of your way of working right now. If you have seen this file 10 seconds ago, most likely it's somehow kind of dependent on the files that you are editing right now. So we are using all this data, we are collecting it into one prompt, and we are sending it. What can we do else? There is a problem that most of the language models have kind of a context that is pretty small, like 8K tokens. It's about 32K of characters, 32,000 of characters, which is a lot, but not for the big monorepository. And that is why we need some so-called on-device machine learning. So we are training additional classifiers, some things that are trying to understand whether, for example, this file is related to that file. For example, you are writing docker.kt, something about probably Docker. And we have files process.kt, client.kt, and docs.kt. And we need to kind of understand which files actually should be added to the context and which are not. And since docs.kt does not seem kind of as a file related to the docker.kt, most likely we would drop it. But actually it can be also watchdogs. Because of it, we will have to take a look into the file and try to understand what is going inside to understand whether it should be added to the prompt. But it can be done with on-device ML, with different ways of finding similarities, with some formal methods, and we are trying to create the context that fits you most. So we get this kind of a way of implementing things. We have our IDE that you are kind of editing main.kt. We have some on-device models that are running and trying to find whether we are, when we are willing to generate specific completion, whether to this completion this thing is related and this thing is not. We have some context collectors that are providing data about libraries, about language, about, I don't know, anything else, about your history in the terminal, anything, right? It depends really a lot on completion. What is, by the way, very important that most of the features that are context collecting, they, I think, even have not been yet released in EAP, and they are called smart features, so that you kind of able to disable them. And in that case, we will not be collecting context, we will be sending only the information that is extremely needed. For example, if we are willing to generate completion, we are not able to generate it without seeing your file. So you have to send it. But everything else can be disabled, but in that case, probably the quality would be worse. Yeah, so we have pretty simple implementation. IDE, on-device models, context collectors, API, inside some language models that are running for one-line code completions, models that are running for multi-line code completions, and some third-party LLMs. What can we do with it? We can obviously make completion. We can provide explicit request to the model. That is the way actually it's looking. It's my drawing in Sheets, but in Google Slides. But still kind of this is the way it's already working in Fleet, and hopefully at some point would be working in IntelliJ. You are kind of just using special input that is embedded inside your editor, and you are saying, generate an example of language model usage, you are hitting enter, and we are sending the request, the additional prompts about what should be generated, the context to a large language model, and it generates something. We can also implement AI-driven intentions. There is also prompts, but if, for example, you want to explain some code, we would not have only to kind of send this specific file. It may be that this file and this specific method requires some additional data for a large language model to understand what is going on actually. Since you may have kind of a very specific, very hard domain logic, and we need to upload additional files to a large language model as a part of prompt to see kind of what is going on. Yeah, so it's pretty easy to implement something with large language models. It would be working out of the box, pretty nice. But the last question is whether do you need large language models in general. Large language models nowadays are very easy. They would be working out of the box, but very expensive way to get working feature. So intentions, anything is basically implemented very easily. You can just send in the prompt, talking with it like a human being. You may, I don't know, get some course in prompt engineering, check some OpenAI cookbooks or any other cookbooks. But in the end, kind of you are implementing the thing that is interacting basically with something that is very much perceived as a human being. So you're just telling it that I need this context, please generate something. But unfortunately, it's really expensive. And some features still can be implemented with smaller models, like one-line code completion, and with fine-tuning. And here we are coming kind of to the last section, which is also important, is large language providers and inference. For those who do not know, inference is basically the way of calculating your trained model on inputs to get outputs. As you remember, we had kind of a classifier that has golden retriever that tells us whether the golden retriever is a golden retriever or not, and the calculation process of executing this classifier is called inference. And basically, all the things you would hear from machine learning engineers would be either about training or about inference. And inference is extremely important because it's the primary cost of any AI service. OpenAI, Google, anyone else are mostly working not on training the biggest model, the most smartest model, but are working on training the models that would be least expensive and provide decent quality. And nowadays, inference is extremely important also because we have kind of a Llama 2, which is quite good, but it's also very hard to infer it. And nowadays, it's also competition about inference. The cheaper you are able to run your model, the more competitive you are. So, yeah, why it's important? We need to kind of understand when you need to kind of get the large language model and when you need your own machine learning. And specifically in case of JetBrains AI, as you may have seen, in most of the cases, we're actually right now using large language models. Large language models are really hard to train. It takes, I don't know, 128 GPUs and 11 days for 1 billion model. And if we're talking about ChatGPT, it's 175 billion model. So it would cost a lot, and it would take a lot of time, and you still need to know how to train it. But what is also important, it's almost impossible to beat LLM providers in cost per token for general models. So if you are kind of, I don't know, Snapchat, and you are willing to provide chat, you need to go to OpenAI and get ChatGPT, because it would be the least expensive option for you, because you are actually trying to compete on the market of OpenAI. And OpenAI are the best in both training right now and inference right now. You can also go to Google, for example. They also have quite good models. So if you want to have some general model inside your application, like in the case of JetBrains AI, we have chat, you need to use some LLM provider that provides you with general models. You can use OpenAI, we are using it right now. You can use Anthropic, which is available through AWS Anthropic. It's actually called AWS Bedrock, and they have Anthropic in it. You can use Google Palm 2 models, and at some point they say they will replace them with Gemini. It has been announced by Sundar Pichai, I think, like half a year ago. And you can use Amazon Titan models that got recently into GA. We are using GPT-4 since it's more or less kind of on most of the evaluations industry leader right now. But still, if you are kind of implementing the thing where you need a general model that is running general thing, just use large language model provider. Do not deploy your own Llama. Do not do anything of it, because if you are able to run if you are able to use large language models provider, it would be least expensive and the best kind of in case of in terms of quality solution for you. But there are some cases when you do not want to get LLM. For example, because it has not been invented here, but also because we have some specific engineers. We have a very specific task. For example, one-line code completion. We have code of specific language, and we need to complete one line. It's pretty simple task, and it would be quite kind of expensive to run it through large language model providers. And you have good reasons to implement something on your own. Let's just take a look at a few examples of them. When not to get large language models. There is a beautiful example. Actually, the same example can be used for writing assistants like Grammarly or anything else. Grammarly are known as one of the best in terms of inference, one of the best in terms of inference price for writing assistants. This is the situation where you need to detect something in background. For example, you have a code and you need to perform bugs detection. The same thing happens with Grammarly. For example, they have to kind of verify your writing, your text, each moment. In that case, running large language model in background is extremely expensive. For example, if we would kind of build it into all the IntelliJ ideas, and you'll be kind of everyone who is kind of giving a consent, it would mean that thousands, hundreds of thousands, millions of developers would be sending the data to us, to JetBrains AI, and we need to have big number of models that will be in background checking it each few seconds. It's extremely hard, and it's not possible to implement with large language models. So that is why, in this case, you need actually some custom model, like Grammarly has the Gector, like we have in Grazie our own model, that is writing assistant model in JetBrains AI. We have own models that we are developing for bugs detection. Those models are smaller models, and they are capable of running kind of online for you each few seconds. Another, once again, pretty simple example is one-line code completion, because to complete one line, you don't have to, you may get better results, it's true, but it's important to kind of complete something. You may get better results, but yeah, but it's important to kind of complete something not as expensive as running, I don't know, GPT-4. We actually had one experiment with GPT-4 for completion. It provides extremely good results, but it costs about 10 cents per request. So it's possible probably to use it as a replacement for Copilot, and it's capable of understanding a very specific domains. We have been trying it on a few internal applications that are using very custom UI frameworks to run, to kind of run and create UI. And it understood this UI framework. It has generated few actions, very good, but the problem is kind of the price. So it generates you one-line code completion that is extremely good and almost always correct, but you are paying kind of 10 cents per request, which is not kind of feasible for most of the developers. So one-line code completion is also a very simple task to run in LLM. You can do it with your own models. And this is the way kind of a JetBrains AI actually is working right now. We have a lot of our own models for one-line code completion, to get metadata, to provide you with embeddings, a lot of models that we are running ourselves. We have some security, anti-fraud, some hosted large language models, and we are using some third-party large language models in cases where it's not feasible to implement our own language models or to do something else, kind of to implement our own language models or to run them and infer them on our infrastructure. And this is the way it works right now. So, grazie for your attention, and maybe you have some questions. I actually had one last thought about Grazie. Why it's called Grazie? It's the reason is that some of you may have seen grammatical correction in IntelliJ, and why I have been providing these examples is that it's basically JetBrains AI is kind of an evolution of writing assistants that we've been developing as a part of Grazie platform. So Grazie platform has been renamed to JetBrains AI platform, and since recently we have a lot of code assistance models as well. And the whole code thing is actually very similar to natural language processing. So it's kind of the way it works. You are doing something with text, you can do the same thing with code. Yeah, thank you once again. And maybe anyone have any questions? Mm-hmm.
Natural human languages and artificial programming languages, because if you write a poem, maybe you write a verb instead of another, and you are fine as well. But if you use the wrong method name or the wrong variable name in the code you generate, it's not that good.
Yeah, that is a good question. Actually, there is big difference in terms of language models in general when you are training something for text or for code, because code and artificial languages are structured languages. And we see it kind of in terms of quality even. Code completion metrics are always a lot better than text completion, because text completion is actually trying to kind of predict what the human is thinking right now about. And in case of code completion, it's a lot simpler to have, I don't know, 300 million models that provides you with great results. And 300 million model nowadays is not considered great results for text. So yeah, there is big difference, but what is important that it seems there is no real reason right now to create special language for, I don't know, machine learning, because basically the way we are kind of creating machine learning models right now is we are trying to kind of make them work with datasets that we have. And that is why kind of the whole machine learning industry has been working on the way how to kind of process the data that we have right now. And that is why it seems like creating special language that would be a bit better to kind of a trained model on, because it has, I don't know, some specific structures or something else, would not be good just because you would not have enough data to train it. And that is why, for example, we see that for Kotlin, code completion is in most of the cases worse than for Java, because there is a lot of Java code and there is not as much of Kotlin code. Yeah. Thank you. Any other questions? Yeah.
What's the energy cost for an inference or to do an inference on LLM?
You mean energy cost like in watts? That is a good question. Actually, right now we're running it on GCP, I think, so we don't know kind of specifics, but it's quite expensive. If we are talking about large language models, you can run Llama 2 of 7 billion or 13 billion parameters. It can even run on your laptop. The only reason why we are not running it right now is because it can run on your laptop and nothing else can. So basically, either you are running Llama or IntelliJ. Yeah, but it's a lot, I think. I think in case of OpenAI, I don't know, it's probably millions of dollars they are spending only to energy. And that is why probably most of the large language model providers right now have only one side of kind of a the only place where you can kind of access the model. So OpenAI is deployed to USA. Google is planning to deploy to EU, as far as I know, but at least as far as I heard. But still, it's kind of a very specific deployments that require, as far as I understand, some additional efforts from infrastructure teams. So they're actually kind of bringing, I don't know, 300 GPUs, a lot of new, I don't know, resources, energies, and so on and so forth. So it's actually even building side to create new large language models that would be running in EU or any other region. I guess my time is up. So thank you once again, everyone, and see you at the booth.